Heidi ho, everybody. So, we've been talking about numbers, some number sets. The other day, we talked about constants versus variables, and I started thinking about different real world examples of what's going on. Today, we're going to talk about, we're talking about terms like terms, right? Today, we're going to talk about combining like terms, okay? So, identifying what like terms are is wildly important to be able to know how to combine them. Again, this aspect of math is practice, okay? I know we're all going through a thing right now, but what fascinates me in the coronavirus is that this is real and actual live math streams. And you're seeing all these models that people are coming up with predicting things of should we open the economy, blah, 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 all this, that, and the other thing. That is real math happening in real time. As a predictive measure that's used to make decisions. And that's how most math is used. There is also, of course, huge trains of mathematics that you dream up, and then later you go, that's pure math, where you dream it up, and then you go, oh man, this says that we could probably time travel, and then you try that too. And it is mathematically possible. We don't have an actual real Tony Stark in the world, so it hasn't happened yet, but it's mathematically possible. But so we're practicing. So combining like terms, I like to think of it as cleaning up your sock drawer or putting away your clean laundry. You've got your shirts, you've got your socks, you've got your undies, and you got to pile it so you know where to find it later on. You need it all in the same pile. I do not know a single human being. Now, I don't know everybody. I know a lot of people, and we don't always talk about this, but who just dumps all their crap into a big pile. Because then you'll never find anything. My son is often like, Mom, where are my socks? And I look in the sock drawer, and if they're not there, I look in the clean clothes pile, and if they're not there, I'm like, they must all be in dirty clothes, right? Which sometimes happens. But there's a process, right? And it's because it's organized. You don't go, oh my gosh, I need a clean pair of underwear, and then just go, well, I don't know. Maybe some will descend from the heavens upon me. No. We know where to go because we've organized it for ourselves. That's what we do. If I need coffee in the morning, I don't suddenly go, oh gosh, what'll happen with coffee? I just made it yesterday and the day before that. I know the process. I know where I put the coffee. I know where the coffee pot is. I know where to get the water, right? Why do I know that? Because it's basic organization of my life and your life and life, right? So combining like terms is just really rudimentary organization of a math equation, okay? Or a process. The key for you and the takeaway for you is recognizing the socks versus the underwear, right? What are like terms? What makes that a like term? Why do they go together? That's the key component, okay? You're just saying, that doesn't belong in the sock drawer. Those are undies. And in fact, they're not my undies. They're your undies. Right? We all have different size underwear, okay? And we all like to wear certain things. I'm not telling tales out of school. It's just true. Right? So you're like, that's yours. This is mine. Those are like terms. We're just organizing, okay? Are you thoroughly uncomfortable? Just go get yourself some coffee. It's going to be fine. It's going to be fine. Okay. How do I know this is my sweatshirt? Because I bought it and I wear it. And it goes in the sweatshirt drawer, okay? All right, so let's just combine some like terms, all right? I'm going to do just a bunch of terms, okay? It's like the laundry pile, and we're just dumping it out. But to keep things relatively simple, I am only going to use two variables, okay? So what variables should I use? What do you think? M, I think that's a good one, M for Minnesota. And what else, you guys? P, okay, M and P. Yeah, why not? Minneapolis and Paul. Sure, we'll do that. So here are our variables, all right? I'm just going to put them up here because they're things, okay? So any combination of these and constants are going to work, all right? So watch me work my magic. I'm going to take volunteers. What should I say? Five. Yep, 5. That's a good one. How about 4? Yeah, military police, except for don't. Yeah. Okay, how about 6P? I almost threw W out there. That would have been dumb. Okay. M. -4M. 3m squared p. Yeah, that's right. That's right. Uh-oh, I'm out of my columns. I'm going to try to, hold on. I'm going to try to make this kind of squared p, I said, right? -9. Yeah, that's right. Someone said it. One of you guys did. I heard you. I heard you. I heard you through the digits. I heard you in outside of space and time. We're looping all back on each other. It's totally fine. How about, I almost wanted to say W again. How about 7 and MP? If there's nothing written there, what number is it? It's a 1. Okay, I'm getting a lot of these. A lot. 4, 6P, and 2m squared MP squared. All right, do we see all these? Okay. So, which are the same? So let's just kind of roll through. I have m's, I have p's, I have squared p's. Oh, well, I have MP's. I have m squared p's. I have m p squareds. And I have constants. Oh, this is getting out of my pile. Constants. So here are our categories. It's like a Jeopardy. Do-do-do-do. You know what I'm going to do? I got to do it. I got to do it. I'm going to put this down on my knees, and I'm going to do our tilt-a-whirl. I got to do it. All right, ready? Don't miss me too much. Do-do-do-do-do-do-do. All right, I got to back up. Oh, man. Everything's just getting so crowded. It's all crowded. Okay. I don't have room for it all. I live in a tiny house in a tiny world. Okay. So I'll hold it up a little bit. And now we're getting glare. Okay. All right. So let's just go through these. 5 is what? 5 is a constant. So 5 goes way over there. Okay. We took care of 5. 5, we're done with you. What about 4 MP? Well, let's go over here. Here are our categories. Here's our MP category. We have 4 MP. All right. We took care of this one. Right? 6P. We're done with this. Right? 12M. 12M. 12. Done with that. Okay? -4M. Oh, that's also in the M category. But don't forget it has a negative. -4M. Okay? But we're done with this now. 3. So we're over here. 3. I know you're wondering why did I do MP squared? Because I'm a jerk. That's why. Okay. We've got -9. -9 is what? There's no constant, or excuse me, there's no variable, so it is a constant. Don't forget it's negative though, so over here in our constant category, -9. I knew this board was heavy because it's starting to get bothersome. All right, done with that. 7M. Over in our M category, we're done with this one. Okay. MP. If there's nothing written here, that's an implied 1. So when we add these, I'm going to put a 1 just in case. When we add them, that matters. But we're done with this for now. 4. There's not an M or a P, so it is a, survey says, constant. 4. Goodbye, 4. See, do you see how I'm crossing these off because I'm reorganizing them? Okay, they're not in the drawers yet, but they're in their piles. 6P goes in the P pile. Ooh, 6P, another 6P. These are both separate though. There's different socks. Okay, and finally, 2MP squared. You gotta just totally mess that up. 2M. Oh, that's a crazy gray squared. All right, so we piled them up. That's all we did. I combined the like terms. Now, well, I'm going to scooch forward again because I'm going to knock over my built-in, except for it got unbuilt in, actually. It's a 99-year-old house. So I just piled them up. Now, sometimes teachers and people will encourage you to be like, find your constants and you'll circle the constants, right? And we'll underline the MPs, right? And we'll box the M's. There are different ways. But ultimately, you want to know what pile they belong in, okay? Then if we combine these, we add them up, okay? We're going to add them up, which I'll do in another video real fast. But if we wanted to, How many M's do we have? Well, we have 12 minus 4, which is 8, plus 7, which is 15. How many P's do we have? 6 plus 6 is 12. We have 12 P's. How many MP's do we have? 1 and 4 is 5. Well, we just have this one for MP squared, so we have 3, right? And we only have this one for M squared P and MP squared. It almost sounds like MP3. And then for our constants, we have 5 minus 9 plus 4. Holy bananas! Our numbers for constants is 0. So it ends up going away because we have 0 in our constant category, but we don't ever write 0. It's implied to just exist all over the place because it's the identity. Remember? Go back if you have to watch it again. Okay, so our constant, if we were to write this out, our constants would go away. We would not write plus 0. So those are combining like terms. You're organizing your laundry. Nobody puts their t-shirts in with the towels. It just doesn't make any sense. Why would you put your t-shirts in? Nobody puts their long johns in with the kitchen towels. Why would you pull out your long johns with the kitchen towels? Nobody puts the kitchen towels in their sock drawer. We all know how to organize these things. And if you don't, you usually get yelled at from your mom. So that's the thing too. Pick up your clothes. I'm still learning. All right, stay safe, stay close. Learn your math. See you later.